Okay, so today we're going to look at naming alkenes. Alkenes are very easy to spot. You just have to look for the double bond. So unlike our alkanes that have all single bonds around the carbons, one of these might have a double bond. So you have to look for that for your alkenes. Okay, they're also, as you see, unsaturated. So each carbon still has 4 bonds coming off of it, but there's a space here and here that we normally have filled with H's for our alkanes. So they're not saturated with our hydrogens anymore. Now, if you look over here, we can't have methane, because to have a carbon-carbon double bond, you need 2 C's. So methane isn't actually a thing at all, okay? So you'll never come across methane. Ethene, so on, propene, butene, pentene, etc. all have more than 2 C's, so you'll see them. And then we also have our halogen side groups and their prefixes if we come across those. So let's try and name this one here that's right in front of us. So we have 3 carbons, so that means it's prop, and because we have a double bond there, we can call it propene. Okay, now the first 3, while I'm still on this page, are gases. So it's very like your alkanes with the first 4 that were gases. All of the rest of them are liquids. Okay, moving down to the next one. How many carbons are there? They're all the exact same. They're actually just different arrangements of your 4 carbons, and you call those isomers. So this is your first isomer, your second, and your third. So they're missing their H's, so I'm going to just put them in. Each carbon can only make 4 bonds in total. So make sure that you don't accidentally put in an extra one anywhere when you're drawing them. Okay, so we've it saturated there with as much H's as we can. That's one structure. So you can see that the carbon is on, the double bond is on carbon 1, and it's reaching out to carbon 2. There's no point in me then as a different structure, instead of drawing it here instead, because it's literally a mirror image of that. Okay, so if there's any mirror images, that's not actually a different isomer at all. So you have to think about it as every single way. So if it's on the exterior already, that's one isomer. Then for the second one, as you see, we didn't put it on the far exterior because that's literally the same thing as this up here. We've now put it in the middle, so it's on the carbon 2 and carbon 3. Okay, and then the last one is when you can actually move a carbon to a side group instead. Now, I'm going to give you a second to try and actually name that. So pause the video and try and name the third isomer that you see there. So look up here for a second, get your number of carbons, and now try and name it. Okay, so the longest chain, 1, 2, 3, or 1, 2, 3. So it's definitely going to be methane, ethane, propene. Okay, now there is a side group there, so it's going to be called methyl propene. Okay, now moving on downwards, we're going to try and name this one here. So when you're naming them, unlike looking for the smallest number to go by the side groups that we see here, we need to make sure that the number is the smallest where the double bond occurs. So we'll number them this way first, and then the opposite way. So which way, blue or red, will the double bond receive the smallest number? So it will be in the reds. So we'll just rub out the blues there. So the reds. So let's look at that one. That would mean that there's 1, 2, 3, 4, 5, 6 carbons. So it's going to be hexene. And the double bond is on the second carbon. So you must go to hexene. You need to represent where that double bond is. After that, then, we have a chloro group, which is on carbon 6. So I'm going to go 6-chloro for the time being. And then we have 2 methyl groups on carbon 5. So you must go 5, 5 dash dimethyl. So then C comes before M. So you're going to write the chloro first, alphabetical order. So 6-chloro dash 5, 5 dimethyl dash 2-hexene. And you can also see it written as this sometimes. Hex 2, the little dash there, ene. So the 2 might be in between the hex and the e. Okay, so now I want you to try and attempt to draw the one that you see here. 2-bromo, 3-methyl, 2-hexene. And we have the second option of writing it here as well. So pause the video and try and give that a go. Okay, so the first thing we need to look at is how many carbons we have. We have 6, so we'll draw that in first. Now, the double bond is on the second carbon. So there we go. So we've done that part. Then, on the third carbon, we have a methyl group. So we go to the third carbon. And then on the second carbon, we actually have a bromo group. So it'll be R. And then everything is done, so we can then just add in our H's, but make sure to check that each carbon only has 4 bonds connected to it. Okay, so double check. This carbon here has 4 bonds. This carbon here has 4 bonds. This one, this one, this one, and this one. Okay, and it's still unsaturated, as you can see. We still have gaps here and there. So we're on the right track. Okay, just to bring your attention back to this one here. And I'm going to actually saturate it with H's as much as I can. Okay. So, you don't need to actually represent where the double bond is here, because again, if you imagine a mirror image here, there's actually only one structure, one way of making this bond, okay? And that's exactly the way you see it there. So you don't need to actually put in any numbers. You don't need to say carbon 2 for where the methyl group is, or you don't need to say where the double bond is, because it can literally only happen in that structure. So just be careful with those. You don't need to put those numbers in. And that's it.